There is a difference between average rate of change and instantaneous rate of change, which we'll come to at a later time. And I know those are two terms that you've come across last year in pre-calc as well. Average rate of change is what we're going to talk about now. This is what happens over an extended period of time, okay? So it's how something changes over a certain period of time. So the average rate of change of a quantity is the amount of change divided by the length of the interval, so the time it takes. And remember what we had said before is if the thing that's changing, if that's given to you as a function f, then what you do is you take f at the end minus f at the beginning divided by the total time, right? So let's talk about interval for a minute. Interval is a like it's when time runs for a while, okay? That's a time interval. So an interval, for example, will start at t1 and it'll go to t2, and the way we write it is like this, okay? So starting at t1 going to t2. So if the thing that's changing, if that's given to us as a function, then the function at t1 and the function at t2 are what we're going to look at in order to figure out the average rate of change. So the function at t2 minus the function at t1 over the total time, that'll give us our average rate of change. We don't care really what happens in the middle, okay? All right, so let's take a look here. Now, if I have t1 and t2, right, and if those are on the horizontal axis, then f is on which axis? The vertical axis. So until now, we were always looking at, t and y. So just know that t, the horizontal axis, that was like our x2 and x1. And f, the vertical axis, was our y2 and y1. So remember what we had was y2 minus y1 over x2 minus x1. Okay? Our horizontal axis, the x, are now the t's. And f of x, or f of t, are the y's. Okay? All right. So here it says to find the average rate of change. And the first interval we're given is 0 and 4. So between 0 and 4, right? What is the average rate of change? So you see how this function at 0, at x equals 0, the y value is here. At x equals 4, the y value is here. So we want to know, we can tell that the y value changed, right? We want to know how fast did it change, okay? So what we're going to do now is we're going to take f of 4 minus f of 0 over 4 minus 0. Okay, so let's remind ourselves what's happening here. We're going from this point to this point. All right, let me make that line a little bit more straight. So we're going from that point to that point. We're obviously changing our position. We want to know how fast we're changing our position. Okay? All right. So what's f of 4 in this problem? 3. Minus f of 0 is 1 over 4. So that's 2 over 4, which is equal to 1/2. Okay? Now, just for fun, do you see that red line that I drew? What's the slope of that line? 1/2, 1 over 2, right? Is that a coincidence? It's not a coincidence at all. So when we find average rate of change, all we're doing is we're connecting the 2 points on the interval, and we want to find the slope of the line that connects them. That's what we're doing. That's average rate of change. Okay? All right, so let's do another one here. We want to find the rate of change of this function, and this time it's a complicated function, 2 plus sine of t. Okay? And we're going to go from 0 to pi. Yes?
So do we have to redraw the line? Is that a necessary thing to do? You like drew a line between some of the dots,
No, I'm doing it. It's necessary for me to explain it to you. Okay? So here, take a look. We're going from 0, and this is f of 0, to pi, and this is f of pi. So take a look at the line that connects them. Okay? Well, let's see. So this is going to be f of pi minus f of 0 over pi minus 0. Okay, so what's f of pi? 2 plus sine pi. Right, and then minus 2 plus sine 0 over pi minus 0. So let's go through this in case you're not given the graph, right? So this is going to be 2 plus what sign at pi? 0. Minus 2 plus what sign of that was 0. Sign of 0 is 0 over pi. So this is going to be 2 minus 2 over pi. 0 over pi, which is how much? 0. Okay, 0 over pi, which is 0. All right. So now let's take a look at the line that connects the two of them. Okay, at the initial point, it was at 2. At the final point, it was at 2. How much changed? How much did it change from the beginning to the end? 0.
That's why it's 0.
That's why it's 0. There is no change, right? So if we're looking at how fast did something change, well, it didn't change, so it's 0. All right? Also, if you have a horizontal line, right? What's the slope of the horizontal line? 0 slope.
0 slope.
Okay? Because there is no change. Yes.
So do we need to show our work for those kind of problems? Can we just like 0?
Well, normally you're not going to be given the graph. You're going to be given the equation only. So yes, work. Okay? All right. So take a look at this. The figure below shows the growth of a fruit fly population in a controlled experiment. So let's find the average rate, the average change, and the slope of the secant line PQ. Okay, let's talk about this for a minute. Secant line. Okay, back in geometry, we learned about tangent lines and we learned about secant lines. So a tangent line touches a circle, let's say, at how many points? 1. A secant line will touch a circle at how many points? 2 points. Okay? Now, in all of these, when I looked at the first point and the second point and I connected them with a line, at how many points did my line touch the graph? 2 points, right here. So that's a secant line. Here it touched the graph at 2 points. That's a secant line. So here, when it is asking us for the slope of the secant line, all that is a line between 2 points on a graph. Okay? So a secant line is a line between 2 points. All right, so now it says to find the average rate of change. Okay, well, look at the graph here. We have the population, right? So the y-axis is given in p, as it's the name of the function is p, and the horizontal axis is t, right? So if I want the rate of change, it's how much the p change versus how much the t change. So one thing is P2 minus P1, right? That's the change in P. In short, we can write that as delta P. So delta is the capital letter in Greek. It's the capital D, right? That's how you write delta. I just wrote a triangle here.
Oh, I thought that was a D.
No, it's a triangle.
Oh.
But in Greek, it's like the D sound. It's the D. Okay. So when I have delta P over delta T in here, all it is the change in P over the change in T. Okay. So in going from this point to that point, how much did the P's change? From what to what?
From 23 to 45.
Okay, so
No,
that's T. Very good. So this is T and this is P, right? So what was the final amount? 340 minus the initial amount over the final amount for T minus the initial amount for T. Okay? So this is equal to 190 over 22, and that's roughly 8.6. Okay? So that's the average rate of change. Okay, that's the average rate of change. Now the second question is, what is the slope of the secant line? This is the secant line. So what do you think is the slope of it? It's the same exact thing. Okay? The reason for this exercise is to just reiterate, okay, that average rate of change is the same as slope of the secant line. All right? Yeah.
Is that going to be just with the secant slope, or is that just the secant line, or is that with also tangent line?
No, just secant line. So the highlighted part here, when we talk about average rate of change, that's the slope of the secant line. Okay? Later on when we do tangent line, you'll find it's completely different. Okay? All right. So now, look at the secant line. How did we get the secant line? We chose 2 points. Is that right? And look at where the 2 points are. They're pretty far away from each other. Okay? What if I took 1 point and I moved it very, very close to the second point? So for example, what if I moved this point up here closer to the first point? All the way here. Well, would it be the same? Now, if I drew a line between those 2 points, look at what that line would look like. Is that the same? No, it's not the same. So you know what happens actually? Here, look at the green line. At how many points is it touching the graph? 2. Look at the blue line. At how many points is it touching the graph? 1. So when you bring the second point very, very close to the first point, what happens is the secant line transforms and becomes a tangent line. Okay? When that happens, now I'm looking at the average rate of change between, not from 23 to 45, but from 23 to like 23.00000001, which means I'm looking at the rate of change at 23. All right, do you see what I'm doing? So rather than looking at the average rate of change, I'm now looking at the rate of change at that point. Yeah. Uh-huh.
Would they give you like a certain area that you feel like what we did before?
Yeah. Yeah. If they're asking for average rate of change, they will give you the interval over which to do the average rate of change. Right. So if they give you an interval, find the average rate of change over this interval. You have to choose those 2 points, the beginning and the end. Okay?
And if they don't, does it not matter?
Right. But they will always give it to you. Yeah. Okay? All right. So let's talk about tangents. Okay? Now, if you want to, okay, so let's talk about this for a minute. Suppose you're driving from here to, I don't know, you're going on a road trip, okay? It's like 500 miles, all right? Not too far, 500 miles. And suppose it takes you like 10 hours to get there, okay? I know, that's a really long time. You stopped along the way, okay? So 500 miles, and what did it say? What did we say? 10 hours to get there, okay? What was your average speed in miles per hour? 50 miles per hour. Suppose you drove 500 miles, but it took you 5 hours to get there. What was your average rate of change? What was your average speed? 100 miles an hour, okay? Now, let's say it was 100 miles an hour. Would you say that at every single point you were driving? would you say that at every single point in time you were driving 100 miles an hour? No. If your average rate of change, if your average speed turned out to be 50 miles an hour, were you driving 50 miles an hour at every single point in time? No. Sometimes you were going 70 or 80. Sometimes you'd see a cop and you're going like 60. Sometimes you stop, you're not going at any speed at all. So you weren't going at 50 at every single point in time. However, was there ever a time, do you think, that you were going at 50?
Yes.
Yes. Okay? So those are different things. Now, if it took you 10 hours and you were going 500 miles, so on average, your average speed was 50, right? Now, suppose at some point your friend calls you and says, hey, you pick up and they say, okay, look at your speedometer right now. What speed are you going at? Okay, and you look and it's like 67.5. That is your speed at that time. We call that your instantaneous speed. Okay, so that we get from the tangent line. Okay,
We get the instantaneous from here.
correct. You get the instantaneous from the tangent line.
Could you also say instantaneous velocity?
Huh?
Can you also say instantaneous velocity?
Yeah, instantaneous. That's the instantaneous velocity. So again, all this, okay, is telling us what I said earlier and what I'm saying right now. So that is the instantaneous velocity. Now, how do we get that? We get that by taking this point and bringing it closer to our first point. Okay? So take a look at this. This is point A. So here I have A comma f of A, right? This is f of A. Okay? Now, if I go a distance h away, now I'm at A plus h. Everybody with me? So, if this was f of A, then this would be what? F of A plus h. Now, I chose how big h was. Here, it's huge. But if I make h to be smaller than that, then my point will be here. And f of A plus h will be there. But if I bring it even closer, then my point will be here. If I bring it even closer, then my point will be here. And here, take a look. F of A plus h is right there. You see how close they are? Now, if I were to connect those 2 points, what does it look like? It looks like the other one, a tangent line. If the 2 points are so close to each other, it looks like a tangent line. Okay? So how does that happen, huh? So how did that happen? From here to here, we had gone a distance of h. But if I make h really, really tiny, right, that's a tangent. Technically, but we define this as what happens as h approaches 0. So as h approaches 0, then it'll approach and become a tangent line. Okay? So here we found the slope of a secant line. Now let's talk about the slope at a point. Okay? So the slope at a point is now, take a look. It's f of A plus h minus f of A over h. Is everybody okay with how we're getting this? So this is the final minus the initial. And how much did we go over? H.
Didn't we do that
Earlier. But now we're going to add this. Okay, what happens as the limit of h approaches 0? Right. Right. Okay? So we did this before, but now we're saying what happens as the limit of h approaches 0. Okay? All right. So let's take a look at this one. So it says find the slope of the parabola at the point 2, comma 4. So now right there, it's no longer going to be a secant. At that point, we need to find the slope. Let's investigate this for a minute. If I'm here, right, take a look at the tangent line there. That's the slope over there. If I'm here, look at that. That's the slope over there. Are those two slopes the same? No, one is negative, one is positive. If I'm here, look at that. It's a steeper line, so the slope is different. So when you look at slope at a point, at each and every single point, the slope is going to be different. So now I want to find the slope there. The way we do that, all right, is f of a plus h minus f of a as h approaches 0. Okay? So let's do this one. H is how much you go over, but you'll see that because h is a number that we introduced, when we do the math, it has to go away. Okay? All right. So the slope of the tangent line, is m equals the limit as h approaches 0 of f of a plus h minus f of a over h. Okay? All right. So let's do this. What is a in this case? This number is a. That's the x value. Okay? So m is equal to the limit as h approaches 0 of f of 2 plus h minus f of 2 over h. Right? So first plug in the a. No. So first we substitute a. Then, now we're going to substitute this into our function. So what's our function? It's x squared. So f of x is x squared, right? Take a look here. F of x is x squared. What's f of 2 plus h? 2 plus h squared. Good. Minus, what's f of 2 then? 2 squared. All over h. Yes, every single time. Even. Well, this is for h. So h is still there. As long as there is an h in the equation, you leave it. Okay, so this is going to be 4 plus 2h plus h squared. Think back to algebra. Minus 4 over h. 4h. Thank you. And then the 4's will go away. So I have the limit as h approaches 0 of 4h plus h squared over h. What happens to one of the h's everywhere? Drops. So this is limit h approaches 0 of 4 plus h. So m equals 4. Now, I took 1, 2, 3, 4, 5, 6, 7 steps here. If, there are 1 or 2 steps here that you want to leave out, totally fine. All right? But now, okay, so that is the slope at that point. Okay? Questions?
So you always plug in the x value?
Yeah.
Would there be a scenario in which you plugged in f of a, not not just a? Because you didn't use 4 in the original equation, just the answer ended up being.
Right, because the 4 is y, and no, you wouldn't, not in this one. Okay, so the first part of this equation was to find the slope, which we did. The second part, right, the second part says now write an equation for the tangent to the parabola. All right, so now we need to write an equation for this line. Huh? But 4x, but it has to be an equation of the line. 4x squared is not a line. So how do we write an equation for a line? What do we need? We need a slope and a point. Okay? So the slope, so for the equation, the slope is 4. And what's the point? What's that point? 2 comma 4. So point slope form, right? It would be y minus 4 equal to 4x minus 2. This is the equation of the tangent line at 2 comma 4. Either. In slope-intercept form, it'll be 4x minus 4. Either or is fine. Okay? I really don't mind. No, I'm just telling you that that's what it is. Okay? Questions? Okay. F of x is 1 over x. Yeah. Yeah. F of x is 1 over x. All right? Okay, so find the slope of the curve at the point x equals a. Okay? The slope at the curve at any point x equals a. All right, so let's do that one. So this is f of x is equal to 1 over x. Okay? I wrote it like that because in some books it's like the slanted, but just know that that's what it means. So let's do part A. At x equals a, right? We need the slope of the curve at a point. Slope at a curve is this. So f of a plus h minus f of a over h. Okay? All right. Always the same formula. This is the formula for the slope at a point. Okay, so when you hear those words, slope at a point, it triggers this formula. Right, the limit as h goes to 0. Okay, so this is the limit as h approaches 0. Okay, so what's f of a plus h? Not 1 over a, but 1 over... Okay, so f of x is 1 over x. What's f of a plus h? I know I heard it from somebody. 1 over a plus h. Okay? Minus, what's f of a? 1 over a. Okay, all over h. Yeah, now we gotta find a common denominator. Oh my gosh, I know, it's a... I know, right? Okay, so the bottom h stays. Between the a and the a plus h, what's the common denominator? A times a plus h. Okay, here's how I do this. Okay, look at this first denominator. Compare it with the common denominator. What's extra? A. Whatever's extra, you multiply with the numerator, so you get 8. Minus. Look at this denominator, compare it with the common denominator. What's extra? A plus h. Multiply with that numerator, a plus h. If you don't put the parentheses, it's almost like instant death. Okay? It just doesn't work. Okay. So now, this is the limit. So now, take a look at this. Let me combine some steps here. This is going to be a minus h, correct? So that'll just be negative h over a plus h, all over h. Now, the blue h and the purple h are both numerators in their rank, right? And you cancel them out. Okay. This is a numerator on top. This is a numerator on the bottom. It might be easier to see if you did this.
This is exactly like the one on.
Exactly. Okay?
It's like the 1/5.
But it doesn't have to be negative.
They go away. Yeah. Yeah. So this is the limit as h approaches 0, -1 over a plus h. So look at what happened to the denominator. The purple h went away, and so there's just a 1 there. So all you have is this on top. Now, here we go. Can't do more than this. Now we can plug in h is 0, and we get -1 over a squared. Yeah.
Let's get -1 on the top.
What about the h on the bottom?
Oh, and now no more limit, right?
Right. Yes.
You have to carry the limit, but you just like use the full.
Okay. Let me answer this question, and then I'll take yours. Yes.
How did you get -1 on the top?
We got -1 on top because look at the blue h here, and look at the purple h there.
They just cancel.
They cancel. Well, what's 3 over 3? So what's 3 over 3? 1. Whenever you cancel things and they go away, you have a 1. Right?
Right, but why is it negative?
Well, because that was a negative there. It was negative h and h.
So that was negative. That negative is I'm thinking it's a negative there.
Correct. Because 3 over 3 is 1, but -3 over 3 is negative. Okay? So let's see what we did. We had a graph 1 over x, right? 1 over x looks like this. We found the slope at any point a to be -1 over a squared. So if x equals 1, a is 1, the slope is -1 over 1, let's say. Okay? If a equals -1, the slope is same thing. Okay? -1. Now, the question asks you, where does the slope equal to -1 over 4? So at any point, the slope is -1 over a squared. All right? If I'm at this point, the slope is, whatever a is, it's 1 over a squared, negative. Whatever a is, it's -1 over a squared. Whatever a is, it's -1 over a
If
squared.
A is 2.
Okay. So, what if a is -2? It would still square to 4. Okay. So, for part B then, so the slope is -1 over 4. And we want that to equal -1 over a squared. Okay, before you start doing things, let me tell you something. When you've got fractions that are equal to each other like this, if the numerators are equal, -1, -1, 3, 3, 2, 2, 8,000, 8,000. If the numerators are equal, you can just set the denominators equal to each other. It's a thing. So all you have to do is say a squared is equal to 4 and a is equal to plus or minus 2. Okay? That was always a thing. Okay? So, similarly, all right, suppose you have something like this. Suppose you have something like this. X squared over 3 is equal to 4 over 3. How would you solve this one? X squared equals 4. Okay? Does that make sense? Okay.
So it's the numerator or denominator.
Huh? Right. Right. Now, here's one for you. Here's one for you that usually students haven't realized. Okay, so suppose you have 1 over y squared is equal to 3 over 4. What would you do? Okay, if 1 over y squared is 3 over 4, then y squared is equal to 4 over 3. Yeah,
It's actually so cool.
I know.
Wait, can you also
Okay,
do
you
that?
can do that.
That's the butterfly.
Okay, in
You just flip those, right?
Okay.
That's the butterfly.
now it says, at what point is the tangent of this horizontal? Okay, now let's just see what this is. Okay, let's just see what this is saying. At what point? If you see the words at what point, it means what is the value of x? For what? So another way would have this would have read, for what value of x is the tangent blah 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 horizontal? What does it mean that the tangent is horizontal? What does it mean about the slope of the tangent line? 0. So now what I want is to actually find the tangent. Okay, so let's find the tangent. How are we going to find? Okay, so we're looking for the tangent at a point. So we use what? Yeah, the formula. M equals the limit as h approaches 0. Now, it's f of x plus h minus f of x over h. Okay, if a is given to you. Now we're not even given a. We're finding at what point. Okay, so let's compare it to the top here.
Yeah.
The point, here it's saying find the slope at the point x equals a.
Oh.
Before that, it was find the slope at the point 2, 4. Now you need to find the point. At what point is the slope horizontal?
They give you f of x.
So now,
Right, okay, no.
right, so you've got f of x. So now you have to do a general f of x plus h minus f of x over h. And then we have to find the point. So let's go slow here. This is the limit as h approaches 0. Okay, what's f of x plus h? Yeah, that one. It's a doozy. Okay? Minus, okay, f of x is just, notice the parentheses. What happens if you don't put the parentheses?
That's the whole thing.
Yep,
Instant death.
pretty much. Don't even bother after that. Okay, now we just have to be careful. Okay, we're going to distribute the negative 4. So it's going to be 3 minus 4x, right? Minus 4h. Okay, now I'm going to do two things at the same time. I'm going to square the x plus h and get x squared plus 2x plus h squared. Plus, I'm going to add in that negative. So it's going to be negative x squared, negative 2xh, negative h squared. Okay, now I'm going to distribute the negative. Boy, negatives everywhere. One more time. The h was a factor that we ourselves put in artificially. Whenever in math or physics you yourself put in a factor artificially, in the end, it's got to go away. So if it doesn't go away, you made a negative mistake somewhere. Okay? All right. So let's see what goes away here. Negative x squared and positive x squared. Negative 4x and positive 4x. Positive 3 and negative 3. They're dropping like flies over there. Now, let's just write it out. It's worthwhile. Negative 4h minus 2xh minus h squared over h. What happens to the h's? One goes away from everywhere. So now, negative 4 minus 2x minus h. Okay? Now, what's the slope then? As h approaches 0. Negative 4 minus 2x. Fantastic. Okay? So that's the equation of the slope. Okay? Now, at what point is that equal to 0? Or at what point is it horizontal? Well, it's horizontal when m is equal to 0. That means when negative 4 minus 2x is equal to 0, sorry, yeah. So at x equals negative 2. I didn't, I solved for x. So negative 4 minus 2x is 0. I brought the 4 over to this side, so negative 2x is equal to 4. And that gave me that x was equal to negative 2. Okay. Now, okay, the normal equation, normal means perpendicular, so it has to have the perpendicular slope. So in this case, the slope would be negative 1 over 4. So I would say y minus 4 is equal to negative 1 over 4, x minus 2. All right? So in the homework, when it asks for 9 to 12 to find the equation for the normal, that's what it is. Okay? Now, aside from that, just one sec, you're assigned, okay, so 15 and 17, we'll talk about them tomorrow. So if you want to do up through number 11, you can definitely do all those. Now,